Hello, my name is Alessandra Binti Shamsuri. My metric number CD210109. In this chapter, I will explain about the theory. As we can see from the slide, beams are structural members that convey structural load to the column, which then pass the load to the ground. The beam resists internal load and its major deflection is due to bending. The bending is both a horizontal and a pressure element. Beam resists apply loads by producing reaction force and the beam supports. Loads and external force acting on the beam produce shear force and bending moments which cause stress, strain, bending moment within the beam, and beam deflection. Beams are classified into the several types, including the simply supporting beam, fixed beam, cantilever beam, truss beams, overhanging beam, and so on. Okay, the deformation of the beam is represented in such a way that it is donated from its original position. The deflection is measured from the original neutral surface of the beam to the surface of the deformed beam. The configuration assumed by the deformed, the natural phase is referred to as the elastic curve of the beam. The slope of the beam is the angle between the deflected beam and the actual beam at the same point. Next, in addition to the Macaulay method, we can calculate beam deflection using Castellano theorem. Beams are said to be formed on two main constants of strength. In order, the resistance material shear and moment develop throughout their length. If the material is homogeneous and has linear elastic behavior, the shear formula must be employed to construct a beam in this manner. Most of the beams are constructed of the tie material. Calculating the stress trajectory for the beam is frequently unnecessary. Instead, verify that the actual bending stress and shear stress on the beam do not exceed the real allowable bending and shear stress and established by structural and mechanical essays. So that's for the introduction.
Assalamualaikum and hi, my name is Fatima binti Radin, number matrix CD 210133. I will tell about the observation of this lab experiment. For the observation, what we got is first at 3-point bending test. In this setup, the beam is supported at 2 points and loaded at the midpoint, causing it to deflect. Secondly, the cantilever beam test. In this configuration, one end of the beam is fixed, while the other end of is free to deflect. Third, simply support beam test. The beam is supported at both ends and loaded at the midpoint or uniformly distributed along its length. In conclusion, the observation of beam deflection is essential for understanding the behavior of structure under load and is fundamental to the field structure mechanics. Through theoretical analysis and experimental testing, engineers can gain insight into how beams deflect and use their knowledge to design safe and more efficient structure.
Hi, Assalamualaikum. My name is Amira Arif bin Kamaluddin. Matrix number CD210076. I'm going to talk about the calculation. So, the first one is to find the second moment of inertia of the beam section, which is I. So, the formula for I is 1 over 12 BH power of 3. So, example, for brass, after we use the formula, we get 5.22 times 10 power of negative 10. Then we use the same formula for all the other specimen, which is aluminium and my steel. And next is to find the F2 average and W2 average. As an example, for brass at 5 Newton, F average is 0.02 times 10 power of negative 3 plus 0.009 times 10 power of negative 3 over 2. So we get the answer is 0.0000145. And W2 average for brass at 5 Newton, we get 0.00198. We use the same calculation and repeat the calculation for aluminium and mild steel. And next is about the graph. This is a graph that we get from the experiment of graph of load versus deflection for all three specimens. The red line is mild steel, the blue line is aluminium, and black line is for brass. And this is all the three graphs that we get from graph versus deflection, brass, aluminium, and for mild steel. After we calculate the theoretical from the calculation.
Hi, my name is Ahmad Aizuddin bin Ahmad Arshad and my matrix number is CD210204. For the discussion, for the first question is explain your finding from the graph drawn. The graph of load N versus deflection for all the specimen listed shows a linear rotation between load and the deflection. The value of beam deflection for the brass is greater than the steel because brass is more ductile than steel and has a lower rate of elastic modulus. For the second question is construction material selection is an important aspect as to meet the engineering standard and reduce cost. Explain the importance of knowing the characteristic or mechanical behavior of engineering component in a material selection. Material selection is important because to ensure that the product does not succumb to extreme condition and perform well in unpredictable condition. Therefore, the ideal material that is chosen to give us improvising for instant mechanical properties. Thus, knowledge and an understanding of these mechanical properties will help us to select the most suitable material for every condition.
Move with the last topic, which is conclusion. In conclusion, the experiment of deflection of cantilever beam provided valuable insight into the behavior of such structure under applied loads. The key finding revealed that the deflection of the beam increased proportionally with the applied load. In accordance with the theoretical prediction based on beam bending equation, however, discrepancies between the theoretical and experimental results were observed. Overall, the experiment contributed to a deeper understanding of cantilever beam mechanics and their practical application in various engineering fields. That's all. Thank you.